Good morning, everyone. We are back here today with a new lesson regarding the basic elements of electricity. We will be going over a couple of notes I've been listing for you guys to be able to explore this more. From there on, we can move to the circuit theory and solve more problems together in the future. So, to start with, I'm going to be explaining the system of units, the SI units, as you can see highlighted over here. We got quantities, seven basic quantities. We've listed 6 of them over here. The basic unit and the symbol that is used as an SI unit. So we as scientists have specified special units to be able to relate and link works and research together. So therefore we are using meters to measure the length, and the symbol is always meter. Kilogram to measure the mass, it's in kilograms. Second for the time with letter S. Electric current is measured in ampere, and it's the letter A. Thermodynamic temperature is measured in Kelvin, and that's the letter K. Luminous intensity, that's the intensity of light, it's measured in candela, which is CD. We are going to be using these SI units, and we are always expecting you to answer our questions and convert all the other units into the SI units. So once we know that this is our standard, we could move on to explaining the difference between the DC and the AC current. So we have a current time graph, 2 drawings on the left and on the right. We could see that the current along the time is constant all the way, as DC stated here in our picture. As you can see, it's always constant, it's never changing, and that is called direct current. Whereas our alternating current, the AC current, it's going up and down, positive and negative. Usually they are the same value in the positive as they are in the negative, but of course there are some other impacts that might occur to make it different. So basically we're going to be dealing with 2 types of current. We will be considering DC current in our electric circuit course 101. We will move on to the AC one in the second course 102. Direction of currents, once you find an answer, you have a positive, you have a negative. And if you let's say this is your light bulb or whatever component you have considered. If you consider the current coming from here, you just choose and assume the shape and the direction it's coming from. So you always assume it's coming from positive to negative. Then calculate your current. If you find a positive answer, this means that the answer implies that your direction you chose is correct, which is positive side, leaving from the negative side. If you find a negative answer, that means that you also chose a correct direction, but it's on the opposite, negative direction. So you just flip your direction to the other way around. Will be your new direction after knowing the value of the current, after I have found it out. This is one other assumption we are done with. Moving on to the voltage, we want to know what is a voltage. Now I've explained the current, which is the flow of electric charges. For the voltage, we need energy, potential energy, to be able to move the charge from point A to point B. This is the voltage. Of course, energy and the electrons move when there is a difference in charge between 2 locations. So we have the circuit drawn in this place, in this, let's say, image. And then we have 2 points, point A, point B. We want to find, there is a component in here. We want to find the potential charge between this and that, or this and that. So we have to choose 2 points to know what we are dealing with. So to be able to move the charge between this point and this point, this is the V point A to B, let's say. This is point A, this is point B. Whereas if we want to find between A and C, it's VAC. Both are going to have different value, not necessarily the same ones. So we need to have enough energy to be able to move the charges from point A to B. So the potential difference is what this refers or shows us, or it tells us the amount of energy that we need. V could be positive, could be negative. It means the charges are traveling from the upper to the lower side, or from the lower to the upper, depending on the sign. This is another indicator to be able to know the direction. There are circuit elements we need to look at and know their symbols. In an electric circuit, when you're drawing and you have this sign, it means you have a voltage source, or this one as well. The longer side is always for the positive side, the shorter one is for the negative. If you have the other one, the positive and negatives are clear. They are both indication of a voltage inside the electric circuit. These are independent voltage source. Later on in the course, there are going to be dependent voltage source, which are changing depending on a variable resistor. But we're going to be explaining and exploring this furthermore in this course. We got IS to show us the current, and this is the direction of it. And then if the value of is negative, you know that the current is going to the other way down rather than up. This is the graph representation, as you could see inside one of the electric circuit drawings. This is the resistance, and this is how it's represented with this image. And this picture is commonly used among circuit scientists and teachers. We are always sticking to this. Then we are typing the resistance and measuring it in ohms. Independent current source, it's measured in amperes, and voltage source in volts. We know that V, I, and R are linked together through this triangle. V equals to IR, where I corresponds to the current, R to the resistance, V to the volts. And if you have two, you could find the third easy by just replacing one another. That was a quick explanation, a quick brief choice of a couple of topics to go over through before we move on to the next lesson and explain furthermore. We will get deeper into more and more complicated questions. It's going to simplify it together. We're going to be able to solve a lot of questions, a lot of problems. We could understand why the current is moving from this to that point, and where is it going, where is it coming from, the ground, all the other new components such as energy storing components, capacitors, inductors. We will move on to all that all together. I'm going to make more videos, explain them one by one, to start with the fundamentals and move on to more complicated questions. If you've got any questions, just leave a comment below, and thank you for listening.